Part 3. So here we will discuss various other events other than the scheduled maintenance which can affect the mesh network reliability. Okay. Not only mesh network, okay, this can also affect other systems. So one is inclusion of weather events, okay, storms, snowfall in the north. Okay. So all power system networks are exposed to varying weather conditions. Though this in itself is not very critical, failure rates is generally function of weather. Such weather conditions are generally infrequent and not short issue. Remember that whenever failure occurs due to weather conditions, those are infrequent. A short storm, sudden snowfall, sudden rain, like that. During this period, the failure rate increases sharply. So failure rate is not constant, it increases sharply. And probability of overlapping failure is high. Many components may fail at the same time. Okay? Thus, component values are not randomly distributed but constraints to short failures. Though there is no common mode of dependent failure, only independent failure rates are analyzed. So, for finding out the impact of weather events, we need to model the weather state. The first stage is modeling weather. So this modeling can be done using one is normal weather condition, one is the storm or snowfall or things. The problem of weather state modeling is generally restricted to a few number of states. So we have got normal. We write down this. Weather state modeling is generally of three types: normal, adverse, and very strong. You can find many research papers on finding the reliability under weather events. Many modern research papers, various papers are also available. You can work on that. The patterns of duration of weather can be considered a random process which can be expressed like this. So normal during whole period, adverse during the whole period. For example, these are the normal situations, whereas these are the adverse situations. Write down the equation and draw the diagram. So we are basically doing a two-step model. Adverse, using a certain condition, and normal for the rest of the period. This is the individual events, these are individual events, okay, over a time period, whereas these are combined together. All such events are combined together for the purpose of reliability. How to obtain the failure rates? Define lambda as the component failure rate. So we say that the failure rate increases during adverse weather condition. So lambda is the component failure during normal weather, whereas lambda dash is the component failure rate during adverse weather. Okay. Provided in failures per year. Okay. So the failure, write down this. So average failure rate will be the average of these two during normal weather and during adverse weather. And for that, we need to use this formula where N and S, are the duration of the normal weather and duration of the adverse weather for the whole year combined together. See, generally the normal weather duration is much larger than the adverse duration. The values of lambda is approximately equal to lambda cap is approximately equal to lambda, that is normal, because adverse value is generally very for a short event. If the value of NS and proportion of values occurring in adverse weather are known, then we can find out the lambda and lambda dash using the equations. You can see this later. So how to evaluate the reliability of a distribution system for various weather events? The question is how to evaluate the reliability. Again, we don't go much detail for numerical evaluation, only theoretical aspects will consider. The principles will consider. The effect of weather on the reliability is estimated with overlap and average estimated by considering 4 separate cases. So we are going to use 4 separate cases. Initial failure occurs during normal weather, second failure occurs during normal weather. Initial failure during adverse weather, second failure during adverse weather, and here different. Initial failure occurs during adverse, whereas second failure occurs during normal weather. And initial failure during adverse, second failure during usually normal. Okay. So for all this, we can use this equations. Okay. So the derivation I have not given. We can use these equations. Okay. And find out the overall failure. Find out the overall failure. Again, this is one example. We will see the nature of the example. So this is a simple parallel network with two feeder lines in parallel. Please assume that both components are identical and each has following numerical data. See, during normal weather it is only 0.2 failure per year, whereas during adverse weather it is 40 failures per year. Okay, it has increased much. Repair time is 10 hours. Outage time to repair time is 10 hours. And this is the average engine. Lambda double dash is, what is lambda double dash? What is lambda double dash? I think that is the average one. Combined one. Combined one. In addition, it is assumed that the weather states have the following average durations. Normal weather is 200 hours in a year, whereas adverse weather is only 2 hours. So we can use mostly the two weather state model and use the previous equation to find out the reliability. Okay. So why this is important? I am saying that it won't be used for your exam, but if you happen to do research for reliability evaluation between adverse weather conditions, you might have to refer back to this concept. Okay. That is why we are covering this. Next, the first one was weather events. Okay. The next one is common mode failure. So what exactly is common mode failure? So we mention the name common mode failure. For a distributed system, what are common mode failures? Two of the most useful models for implementing a second order overlapping failure event, including common mode failure, are shown in the following slide. We will see only one. Okay, what is common mode failure? The significance of the value of the reply times in these two models should be understood. In this case, in the case of model with separate down states, all repair rates are non-zero and equal to the reciprocal of the common reply time. In addition, all common mode failures are restored by an equivalent common mode repair process. In the case of model with single down state, the value of new quantity is 0 if all the repairs are conducted independently and each component is returned to service separately. So what exactly is common mode failure? So we say that several such events come together and fail together, and that can be of various states. Okay, we will see only one here. So here it is a model for common mode failure with two components in a single down state. You have two components but a single down state. That's why it is common mode. Generally, we have two components which have two down states separately, but here it is a common mode failure. So we have two components but a single down state. Okay, and these are the various events that can go. Okay, but these are the various failure rate and repair rate. So, what is the main purpose? This is simply a mathematical model. The main purpose is that suppose there is a weather event and at the same time there will be a single maintenance event. Okay. So both components fail together. So therefore it is a common mode. So need to draw this. This is just for example and design. So with this we complete the mesh network. So today what we discuss? Today we discuss part 3 we discuss some other factors like weather events and common mode failures, how they affect the reliability of the distribution. So this completes module 4.